16 going to 0. That leaves the h here, right? So you would then have that. Now when you cancel the h's, you have 0 above, right? It's not subtraction. You're canceling factors, so there's a 1 left above, and then you have that expression.
What do you mean because of the plus and minus?
Why plus minus?
Like if I plus.
Oh, for the square root?
Yeah.
The square root function has only one answer. It's an important thing he's saying. Carter?
Baker.
Carters, bakers, potters, all you city business people. You know what a carter is, right? You know what a carter is, right? Like a baker.
Oh.
Somebody who moves a cart around.
Oh.
That's why I call carters. Bakers and potters and tailors and horse thievers, all those people, right? So, the square root of 16. What is the answer?
8.
Plus or minus.
What? What's the answer? Hell it is.
Oh, that's why.
4.
Never mind.
4. So it's an important distinction. So because over here, we're simply evaluating 16. We're simply evaluating the square root of 16. Right? The answer is just 4. Why? Because the square root function looks like this. It does not look like this, right? So when I plug in 16 way over here, the number 4 pops out from here. But negative 4 down here does not come out of this function. Because it's a function. If I included this down here, I'm claiming that my supposed root function doesn't pass the vertical line test, which means it's not a function. Because I have 2 values for 1 value. So it's not a function. So the square root function, which is what we're putting 16 into right now, yields only positives, or 0. Now, what you're used to doing and taking plus and minus is this question. If you have that question, then it's saying, tell me all the possible x's, and when I square them, it gives me 16. So there are 2 answers to that. X would be negative 4, x would be 4. But if I'm just evaluating a number in the square root, the only reason your next step here in certain classes, they say to write this, is because I'm answering a question on the x. That's why. I'm solving an equation. Here I'm just evaluating. All right. So we don't get 2 answers for our limit or limit.
Did you check all this on calculator?
Say again?
Did you check all this on calculator and you graphed it?
Did I?
Oh, could you?
Yeah. What time is it? 8. So, what's that? Yeah.
Can we take a break?
Absolutely, take a break. Come back and start homeworks, and I'll just come around and help you, whatever you need.
Oh, we're done?
What's that?
We're done with the lecture part? Or?
I think you'll ferret out any questions you have for the homework, yeah.
Alright.
I think it's a much better process than you get 1,000 more examples of nearly the same thing.
Man.
Get your hands dirty.
Is it still raining outside?
I can't tell. Yeah.
Yep. And it's windy.
Oh.
Ah, jeez.
Squeeze through.
Professor. Yep.
That one.
So suppose.
First one.
Negative one. Remove the long line. Is that visualized?
It makes sense.
See, they got some crazy questions here. Position of an object moving along a line to make a function of that on the average velocity of the object over the following intervals. Okay.
That continues to foot. What's average velocity?
Differentiation.
Time.
No, because what's average velocity? Differentiation is instantaneous velocity.
So can you figure this out?
I want to ask you a question.
And what is the, okay, so this is for the average form.
How does this work?
How far are you? Oh yeah, you're on.
Yeah, I just started.
I started this morning.
Shit.
Yeah. I'm like right here. Yep, I'm right here.
What chapter is that? Is that still 2?
That's like the last part of chapter 2.
Yeah, so you know what's raining outside too.
Yep, I'm right here.
Whew, I got a while to go.
Yeah, it's very complicated, I can say. Yeah, first one makes sense.
I don't even understand the average and instantaneous velocity.
I don't think he went over that.
He didn't.
Use the graph to find the maximum value.
Oh, duh. X minus.
Progressive or this portion. I'm going to ask you to find the average rate of change, or an average velocity, the same thing, and the velocity is rate of change, right? It's miles per hour, it's distance per time, right? For any function over some AB. And what we're saying is, if this is the curve f of x, in your case, S is whatever, and you're going from here to here, I want to know what is the average rate of change, right? And that is the slope of this line segment, A to B. Okay? So in our case, we said, what was the function? S of t is what?
Let me take a look at it.
Minus 60 squared.
Minus 16t squared?
60 squared.
Minus 6
T squared plus 60 T.
plus 6t
Yeah, 60 T plus 60.
plus 60 t. Yeah?
Then finally,
Over the intervals.
yeah.
The first interval, what's the first interval?
1 and 9.
Okay. So what will be the slope of this line segment? It should be f of b minus f of a over b minus a. That's your answer. That's all it is. Average rate of change, right? So all you're going to do is take negative 6, 9 squared plus 60 times 9, right? That's f of b, right? I took this and I put 9 into it, right? That's this height here, conceptually.
Right.
9 and just subtract off that height there, right? Y, it's all this y2 minus y1 or x2 minus x1.
Right.
That's all it is, right? So minus negative 6, 1 squared plus 60 times 1. So there's the
What is the slope of the
lower height.
line?
I don't know, it's gonna work. Could be upper.
What's
I don't
the
know. Not gonna work out this problem. It doesn't matter. One's higher than the other. And I'm gonna divide by 9 minus 1. B minus a. Right?
Gotcha. Okay, cool.
That's all it is.
Okay.
And they just have to do it like 4 times or something, right? Yeah. Okay. All it is, average rate of change.
What is
This room is too small.